Hi guys, so I want to talk about a solution on Azure for building a RAG app. Now, a RAG app is a kind of application that's used for retrieval augmented generation. I'm going to talk about what that is, but I want to give you the details of how to implement this on Azure using Cosmos DB and using OpenAI. And I'm going to mention some hosting options for the application, but you could really host this on any number of different platforms. But the crux of this is mostly on the AI components as well as the supporting services that make all that run. So let's go look at an architecture and we'll talk through kind of how a RAG app works. And then I'll fill in some of the details about the services on Azure you can use. And then we'll go look at some code about how this is implemented and also how to set it up on Azure. So this architecture kind of represents the totality of what a RAG app would be. And there's really two sides to it. You have this left side over here, which is basically for data imports. And then you have this right side over here, which is dealing with what we might think of as the application proper. Now, both sides are important. It's important to understand how one works so that the other one will work well. Over here on the left is this kind of data pipeline, which is, in my opinion, the harder of the two to crack because there's a lot of details that go on over here. And once you have your data in your vector database, searching that is actually pretty straightforward. But getting the data in there requires a couple of steps. The first thing to do is extract data or to be fed data. However you're getting your data, maybe you're pulling it from a database, maybe you're being fed that by way of some kind of document, maybe it's a document repository that you already own and you're just wanting to use that. You want to basically search that data in some way. So you extract it and you want to land that data. Now, landing the data doesn't mean that you have to create a brand new copy of it if you own it, but if it's something that somebody is feeding you or you're extracting it from an external data source, you probably do want to store that locally in some way so that you can access it at a future date. That'll become important later on. But once you've got that data stored in some kind of raw format, it could be a new database, it could be a file system, maybe blob storage, could be a data lake, whatever you're using. Land the data, and then you want to extract from that data the semantic content. Now, the semantic data is the part of that has meaning that you're interested in. It's the part that you want to search on. So if I receive a document, it has a lot of formatting in there. I don't really care about the formatting as much as I do the actual prose that's got the actual meaning that I really care about for searching on. So I can extract the text portion of that document and kind of ignore all the formatting that's in that document and then pass that to the next step. Now, once I have that data over in the next step, I'm going to do what's called creating an embedding. An embedding is basically a vector representation of that data. And the way this works is we take that text, we chop it up into bits, that's called tokenization, and we pass those tokens into an embedding model. And the embedding model will then return back from the embedding model a embedding, which is basically like I said, the vector representation of that data. And then that's what gets stored in the vector database. So that process has a lot of details I kind of glossed over, and there's a lot of nuance to that, but that's basically how it works. Now, on the right side over here, we have the app. And the app is more like a traditional app, but it's going to be interacting with the vector database. It's going to have an embedding model and an LLM. So we still have a web app, which is going to be running in a browser, and it's going to have an API. And the API is then going to do something with what the client sends. So the client's going to send a prompt over, typically something they type in, or maybe they're using something like speech to text. They're going to be producing some kind of prompt that you're going to receive. And the API is then going to do basically the same thing that happened over here. It's going to take that, break it up into bits, tokenize it, pass it over to an embedding model, and then the embedding model is going to pass back some kind of embedding that I can then use to search my vector database. I'm not going to store that. And what the vector database is going to do is basically do a similarity search on that new embedding that it got back from the embedding model. You need to make sure that the embedding model that you use for creating your embeddings is the same one that you're using for creating embeddings to search with. And once you have that embedding and you search the vector database, it's going to return some kind of documents and some metadata. The metadata is important because the metadata is going to do one of two things. It's going to either have the original text that you use to create the embedding with, or it's going to have some kind of reference back to the raw data that you used to create the embedding with. Either way, you need to extract the original text that you used to create the embedding with. And extracting that text could mean reaching over here to the raw data and just extracting that text again like you did over here, or you just already have it stored right alongside of the embedding in the database itself. Either one is valid. There's really no best case scenario. It just depends on what you need, but you just need to get that original text because that's what you're going to use in the next step. So once you have that original text, you're going to take the prompt that the user sent over on this side, and then you're going to have the documents, maybe you have one or more, and you're going to combine those into a prompt that's going to have instructions from your API. It's going to have the prompt that the user submitted, and it's also going to have the original text from the documents that you had, and you're going to create a single prompt from that and pass that into an LLM so it can process that data. It's going to process the documents based on what the API received from the client, and it's going to try to answer a question or do some kind of analysis on it. And then the LLM is then going to return that back to the API. The API might enrich that with some additional context and then pass it back to the client, and the client can then display it, and they can also further interact with it. So that's how a RAG app works in theory, but the pieces that I'm going to be using in practicality for this implementation is I'm going to be using a vector database on Cosmos DB. I'm going to be using the PostgreSQL offering. I'm going to be using the vector support that it has. I'm going to enable that. And I'm also going to be using a file system here. I could use blob storage or data lake, whatever for this, but I'm going to be using a file system over here. And then for my embedding model and my LLM, I'm going to be using OpenAI on Azure. So I have two different models deployed here, one for creating embeddings, and then I have one that's going to be an LLM. And so I'm going to wire that all up using LangChain inside of my API. And LangChain is just a framework for building RAG apps with. And it gives you the ability to do that with very little code. So combining all these together will give you kind of the full scope of everything that you need to create an application. Now, as far as hosting this application, because it's Python, I can host it in an app service or maybe a container app or Kubernetes, whatever it might be. That's not as important as these other parts that are more oriented towards vector searches, embedding models, and LLMs. Where I host the app, it could be anything, but I could really just pick one and use it, whatever's going to work for my scale and my scope for my application. But in any case, let's go look at how to create some of these resources on Azure, specifically Cosmos DB, and then we'll look at my deployments on OpenAI, and then we'll go to the code and see how we kind of glue all that together using LangChain, and then I'll demo the app. So I'm here in the Azure portal, and I already have a resource group created. I'm going to create a new instance of Cosmos DB. So you can just type in Cosmos DB up here, and you can then create a new cluster here. You can see that I have my cluster already created. I'm going to use the PostgreSQL right here and create a new instance of this. You need to give it a name, and you can give it like Blaze Vector DB1 or something like that. And you can choose your region. The other thing that you need to take into consideration is just your scale. And so if you're basically doing dev work, you can do a single node. You could go back to the burstable option with vCore, and then choose a small storage option, which would probably be fine for dev work. But if you need to scale this out, you can certainly do that because this thing will scale fairly well. You can go up to 64 cores and choose some massive amounts of storage to like 2 terabytes right there. And there is multi-storage if you want to go up to 20 nodes on 96 cores with 32 terabytes of storage, and cost you $300,000 a month. You could do that, but for dev work, probably a single node with burstable core and 32 gigs of storage is probably going to be just fine for my purposes, and it's going to be $18 a month. And I don't need availability zones, but whatever I have here is basically what I need for my purposes for doing a demo. Now, you can save that configuration and make sure you have a name. About the only other thing that you would need to do here is give it a username and password. So a super secure password is what you're going to want to do here. Let me type in one. And then go over to networking. And this is where you want to put in the IP address of your machine. You can have public access and then add the concurrent IP address, which is mine right there, to this rule. If you want to add one for the entire internet, you can do that. Not advised though. You need to make sure that wherever you're accessing this from has the ability to reach into the database. And once you have that added, you can just select the defaults for service managed keys. You don't need tags unless you're requiring them. And then you can review and create. And once you're done, that's basically all you have to do to create this database. And when it's deployed, it just takes a few minutes to do. You'll end up with something that looks like this. And so this is where I can manage it. But the only thing I really need to pay attention to here is the connection strings, which we'll use in a minute, but also the coordinator name, which is going to be my endpoint, my database name, and my admin name, which is where I'm going to be using those to configure my database to use the vector support. By default, it's not enabled, so I need to turn it on. So let's go turn it on using pgadmin. And then once you have it turned on, then your database will be set up and ready to use. So to get pgadmin, it's pretty straightforward. Just go to pgadmin.org and then go to the downloads folder. And then you can download it for your platform and install it. I'm going to assume that you already know how to do that. I'm going to using Windows, and you just launch the application however you do that in your operating system. So once you launch it, you should get a screen that looks something like this. Then you right click on the servers and go to register a new server. You can just give it a new name, PG Vector, or something like that, and then go to connection. And this is where we're going to get data off of this tab right here for our vector database. And so I'm going to copy the coordinator name and use that for the host name. The maintenance database is Citus, the username is Citus, and the password is whatever you supplied when you created the database. Then go over here to parameters and then select SSL mode to require and save it. And I probably typed in the wrong password, so let me retype that password. That's better. Now, I can then right click on this database or just expand it all the way open. And then you'll see a databases too, like this. You'll see the Postgres database, which is the default, and then the Citus database. I'm going to right click on Citus and go to query tool. And then I'm going to type in a command called create extension. And then you just type in vector like that and run that. And I've already enabled this, but I don't need to run it again. But once you run that, you'll enable vector support for your database. So after you've created your database and you've added the vector support for it, now it's time to configure your OpenAI. Now, OpenAI on Azure is usually something that you have to request access to, but once you have it, you can get access to OpenAI and you'll be able to deploy models with it. So the main thing to get here is a couple of deployments going. Now, because of the billing model, you don't get billed anything beyond what you actually use for this. So you go to model deployments and then click on this and it'll take you over to the OpenAI Studio. And OpenAI Studio gives you a lot of tools to interact with OpenAI's models, which is basically GPT 3.5, 4, and a couple other models that they have. Now, I have a couple models deployed here, but the two that I'm mostly going to be interested in are an embedding model and a completion model, because those are the two that I'm going to be using. So to create these, it's pretty straightforward. You just go to create deployment, you select a model here, and you have a couple of different models to choose from. Now, the ones that you'll want to use for embeddings, there's one of these text embedding models down here. So you could use Ada, small or large. If you're not sure, go with Ada, probably for just a default. And then these two have different size context, but Ada is a fairly decent model as well. And the model version, you can take the default and then the standard deployment, give it a name. And then you have content filter will be default. And then you can set tokens per minute. If you just know that you're going to be not using very many, use 1,000 or 2,000 tokens per minute, up to a bunch of tokens. So I was 490,000 tokens per minute. And you can then also enable dynamic quotas. The main thing is that you get a deployment model, which I have right here. I'm using the small text embedding model, which is going to give me an embedding model. Now, I also need a completion model. And so I'm going to use GPT 3.5 Turbo Instruct for that. So you can just select a completion model for this. And you can use this one right here, which would be fine for it. If you're not sure, just select GPT 3.5 Turbo Instruct and give it a name, my completion model. and then it's going to enable the content filter by default, and then you can have so many tokens per minute on that one, and then you can create it. And so once that's done, you'll have two models deployed. Now, remember the names of these, because the embedding model and the completion model are the two that we're going to use. I've been using these for other purposes as well. But once you have your two models deployed, the main thing that you're going to need then is the connection string data for it, rather the connection data for it. And that's going to be inside of OpenAI right here. And we're going to have to get our keys and our endpoint for configuring this. So keep this page open, because we're going to look at some code here in a minute. We're going to get some values off of this, and we're going to set up our environment to basically set up the environment variables for these particular accounts that we have here, not only this one, but also the PostgreSQL database that we have on Cosmos DB. So we'll need a connection string from that, as well as the keys and endpoint from this one. So for this demo, I'm going to be using this document right here, which is just a novel I wrote a few years ago, which is just a Word document that I exported to text, and it's semantically rich. There's no formatting. So there's about a megabyte of data here, and that's much too large for a single embedding. So I'm going to have to chunk this up, and I'm going to use a import mechanism to do that. And I want to ask the LLM to answer questions about this. So I'm going to create a RAG app to answer questions about my novel. So with that, I'm going to use this right here. And this is a script that I wrote to import this. And so this is using LangChain components. So you can see I'm using a token splitter, OpenAI embedding, and also PG vector. So this is basically how I'm going to chunk the document. So I'm going to take it and break it up into sections based on tokens. So tokens are basically just words or punctuations or small pieces of text. And it's going to create a breakup the document based on tokens, and then it's going to try to create chunk sizes around the token sizes, and then have some overlap to provide some continuity. There are other text splitters for this. You can use ones for JSON or HTML or Markdown. You just have to find one that's going to work for your application. And this one works fine for mine. So I don't have a lot of structure to that document. It's just mostly prose. So this is probably about as good as I'm going to get in any case. So once I have my text splitter configured right there, I need OpenAI embedding as well as PG vector configured. Now, OpenAI on Azure needs some parameters, and that's what this right here is going to do. This is the name of the embedding model that I created as one of my deployments. And I need to set some environment variables that look like this. I can get the values for those from the Azure portal. I need to get a key and my endpoint right here. And I put those into my environment variables, and each one appropriately, and then I assign those. So this export is basically what you would use on a Linux context, but if you're using set in a command prompt, or maybe a Docker container, you can set the environment variables that way, or Kubernetes, whatever you're using to host this with. Once you have those set, you'll need a connection string from your database, and you can get that under settings and go to connection strings. You want this PostgreSQL connection URL, looks like this. And this is the one you want. Just make sure you edit it for your password, and put your password in, and then you will have a connection string that you can use in your particular script. So that's what you put in right here. So once you have everything configured, make sure you set your collection name to whatever your collection is. I'm using Citus, which is basically the default one. And you're ready to go, basically configuration wise. And so you take all of that configuration and you set up the vector store using PG vector. There's the embedding model, there's the collection name, there's the connection string, and it's telling it just to use JSONB, which is binary JSON. And this is where all the magic happens down here. This is reading the file. This is breaking it up into chunks, basically taking the document, breaking it up into those chunks we just saw. And this is going from the chunks, just the pure text chunks, into the documents. Now, documents in the context of LangChain are basically the original chunks of text plus metadata. And so you need that document object for the embedding to work. And so if you're just dealing with pure text, it's not going to work. You need the metadata, and then you have the content. And so what ends up happening is you convert it to docs right here, and that's got a metadata tuple, and I'm adding a piece of metadata by adding an ID, because I need that for my database to have a ID field, which is this right here. Now, once I've done all that, I can then call vector store.add documents, and I pass in that documents. And then I tell it what I'm going to use for my IDs right here, and it's going to do it for each document in the docs or tuple there. And so what that's doing behind the scenes is it's calling out to the embedding model, it's getting the embedding and then writing that to the vector database. But it's also creating the tables, creating the schema, it's creating the indexes, it's doing all that stuff for me. So I don't have to do it. And so I end up with a lot of opinionated code, but I also have very clean code that's easy to understand and easy to read because I'm using LangChain. Now, once I have all of that written, I need some way to read that database. So this is writing to the database. I need some way to interact with it and search it. And that's where this little app is going to come into play. And so this particular app is a Flask app. So it's a web-based API. And so it's going to serve an HTML client. And I'm going to basically pass questions into this, and it's going to search a database using an embedding model in my vector database, and then it's going to pass off something to an LLM to get a question answered. And so there's a couple of things that we've already seen. We've seen OpenAI embedding, but we also have this one right here for our LLM, which is our completion model that we deployed inside of OpenAI Studio. I don't need to configure anything differently. I just need to make sure my deployment name is appropriately assigned there. And from that, I also have my PG vector, but then I also have a couple of other supporting objects. I have prompt template, which we'll see what that does below, but basically gives me the ability to create a prompt that I pass into my LLM. And these are just some helper objects to create the chain with. And this is managing the flow, and then this is handling output from the chain, which we'll see down below. Now, once I have all the stuff configured, I have my app wiring that up to run in Flask. There's my LLM, there's my embedding model, there's my connection string, there's my collection name. I create the PG vector just like I did before with my embedding model, my collection name, my connection string, and use JSON B to be true. This is my prompt template. This is just the string anyway. And what this is doing is basically creating the prompt that's going to be passed in my LLM. So what this is going to do is take my context, which is that data that I'm getting from the vector database, and putting it right here, because in the vector database it's storing the original text right alongside the embedding. So it's going to extract that text and insert it right here. And this is the question that I type in on the app that I'm going to run. And so it combines those into a single prompt with some instructions, and then that's what gets passed off to the LLM. So I basically use that string right there with some of the variables, which is the context right here, and then the question. And then I set up a retriever, which is basically something that will grab the documents from the vector store that I used. And we'll see the search down below. But once I've done the search, I can use a retriever to grab those and then do something with them. And then this is a helper method that basically takes all the documents that I grabbed from my vector store and combines them as a single string that I can put into my prompt. And this is where I build the chain. And so the chain is pretty straightforward. Once you kind of have all those objects, you have the retriever, which is going to grab the search results from the vector search. And then I have my format docs that basically just takes all those documents and creates a single string from them. This is my question that I'm using as part of my prompt template. And I'm using runnable pass-through to kind of manage that. And then here's my prompt, which is the prompt that I created. There's my LM, and there's my string parser to handle the output. And these are the routes down here to handle the routes that get passed in. This is just sort of the client right here. And then this is the part that actually does all the magic down here whenever I call the API. And so this gets the data off the post. This asks the question, extracts the question from the post. And this is where it actually does the vector search. So I'm calling the vector store to do a similarity search. And I'm saying, here's my question. And then it does grabs the embedding, and then does a similarity search against the vector database. And I'm asking it to grab 3 documents, which would be basically the 3 closest documents to it. And then from here, I invoke the chain. And so I pass in the question by invoking the chain. And then that will basically follow the chain right here. You're going to get the documents, create a prompt, send it to the LLM, get the output from the LLM. And once I have that, I can then grab that response and then create an object and then pass that back to the client. And then that's what I will display in the UI. So all of that working together It's about 90 lines of code. If I didn't have LangChain, it would be much more verbose. I would have probably a couple hundred lines of code to do this very same thing, because I have to do a lot of the details. I'd have to create the embedding routine. I would have to create a lot of the schema objects. I'd have to work with a lot more of the low level details that this is just kind of using behind the scenes. So I'm just taking the opinions of the framework and just trusting that it's going to handle that for me. And I end up with some fairly straightforward, easy to read code, including white space. So it makes writing RAG apps very easy. So let's go demo this app and we'll see it in action. So let's start the app up. I'm going to type in Python 3 and type in app.py and should get this output. So this is the input, or the endpoint right here. So I'll pop open a new tab, open this up, and I should get this UI. So I'm not the best UI designer, but this will work. So let's ask some questions about this novel. So I'm going to ask it a question about, let's say Jorn. Jorn is a character in this novel, and he comes up later in the book, but I'm going to ask it about what was Jorn's job before he met Kamen and Akira. And basically, he was a mercenary, and so he worked as a soldier of fortune and did a lot of different odd jobs in that context, an expert swordsman. So let's see if this actually provides some answers about that. Jorn was a mercenary before he met Kara Takami. He lived in the West Watch as a mercenary for his entire life due to lack of options in the harsh environment. Well, that's pretty true. Let's ask it again. I should get a different answer. Jorn was a mercenary living and working in the Pussa's Wastelands before he joined Kamen and Akira on the journey. Pussa's Wastelands is kind of the region where this city is. It's a desert city. And Jorn's job before he met was a mercenary in the West Watch. Let's see. Jorn was a mercenary living by the sword in the harsh environment of the Watch. So yeah, all that is true. So let's ask it about Akira's father. That's kind of her backstory. So what was Akira's father's role? How did he relate to Akira? And let's see if this answers a more complex question. So, yeah, this looks good. Akira's father was a highly respected, skilled officer in the Imperial armies. He was known as the Hammer, his ability to root out and defeat the enemies of the Empire. He was a leader of a clandestine unit that conducted off-the-books missions for the Empire. Akira's father was deeply devoted to his family and had a close, loving relationship with Akira. He had a strong and influential figure in her life, and his death had a profound impact on her, which is all true. So that's a really good answer. It kind of answered both of these questions right here. So good analysis, and it was able to grab some good context from the novel. So I'm pleased with this result. It works really well. So I'll make this code available on GitHub, and you can definitely check that out. And I'm not going to create an app and deploy it. I'm just going to provide a kind of some reference code for you to check out. So I'll put the app.py and the import.py out there, and you can adapt it to your liking, but it's actually really easy to do. It's, I think 120 lines of code total using LangChain. And you can use this with PG Vector, with Cosmos DB, and also using OpenAI. And it's fairly inexpensive to run on Azure as well. So a great option for building RAG apps. And you can host this using, again, like app services, Azure container apps. You could put this in pretty much anything that can run a Python app. So very portable code to a lot of different environments. So definitely check it out. If you like this, drop me a comment in the comment section down below. If you want to see more stuff like this, please let me know. If you have any questions, please ask in the comment section. And as always, like and subscribe and share this with your friends. And as always, thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.